Hey everyone, how's it going? Can you hear me? All right. Well, thanks everybody for coming out to JS Remote Conf. I'm super excited to get this going, and we've got some awesome talks lined up today. Before we get going, I just have one or two things that I want to point out. First off, if you registered today, I'm trying to get people access as quickly as possible. So if you missed part of the talk, I apologize, but Mandy and I are trying to keep up on that. And so, yeah, if you're watching this on the video later on, all of these talks will be recorded. And so you'll be able to get them after the fact. We're going to put them on the community forum that we set up for the conference, and you'll be able to comment on them and ask questions and things like that. So keep an eye out for those invitations. They should have already gone out, but like I said, late registrations, you'll probably get those this evening. So without any further ado, I want to welcome my good friend and fellow Ruby Rogues host, Jessica Kerr. Did we lose you, Jessica?
Can you hear me now?
Yeah, there we go.
All right. Can you see my screen?
Yep.
Ready?
Go right ahead.
Okay. Hello. I'm Jessica Kerr, better known as Jessitron. This presentation was developed originally with the help of Dan North, and Jorge helped me with some code. Welcome to JS Remote Conf. This is Complexity is Outside the Code. A long, long time ago, programmers toiled in the language of the machine, and they wrote code on paper tape, and it was very painful. And a lot of people said that there was no way to get it better, that if you wanted better programs faster, you needed more programmers or smarter programmers. And they suffered from the claws of cryptic code and the teeth of common errors until those turned out to be attached to the same bear, which was then slain by a silver bullet of compilers fired by Admiral Grace Hopper. 50 years later, there's no more silver bullet to solve all of our problems because we're no longer fighting a single bear. It's more like we're dealing with a swarm of bats. And there's all these different bats coming at us, and as soon as we knock one down, here comes another. Because there are higher and higher expectations of our programs, and we're expected to get them out faster and faster. These days, I started coding about 50 years after Grace Hopper created the compiler. And we have high-level languages, and we have IDEs, and all kinds of tooling. Oh, and we even have architecture. Back in 2000, every architecture could be described like this: box, arrow, cylinder, which stands for front-end, back-end, database. And then ideally our features would flow through this way, kind of like that. But as we added more features, these boxes grew bigger, and once you've got a team of 50 working on the same back-end application, locked in version control, and the build is broken, nobody can touch anything. Pretty soon our applications turn into a snarled mess. In '99, and it was several years later before I read it, Martin Fowler published Refactoring. And that was supposed to fix this for us, right? Because now we can go back and organize our code and unravel this snarled mess as we go. But the thing is, you can only refactor what you can fit in your brain. And not just you either. every member on the team has to be able to fit it in their brain. All 6 of you, because realistically 6 is about 6, maybe 8 is a size limit for a team of people who all interact and work together regularly. And therefore, that's about the limit of people who can work on a single code base without stepping on each other. And in order to refactor, you have to fit your app in each person's brain. And if that works, great. But more likely, we're refactoring at the level of 3 or 4 classes because that's how much we can fit in our head. And not just your long-term memory either. It's not enough to have understood every piece of the app and be able to recall it need to. You have to hold things in your working memory in order to rearrange and organize them. And working memory is extremely limited. Depending on who you read, we can hold maybe 4 to 7 things in our working memory at once. That's not very many. For variables, for methods, for
Jessica, I can't hear you anymore.
classes. Am I back?
Yeah.
Am I sharing my screen again?
Yeah.
Okay, the green light blinked. I'll watch for that. What did you hear last? Oh no.
I kind of panicked and forgot, so.
All right, well, I'll
4
back
variables. You can only hold 4 things in your mind at once.
up. Okay, excellent. Can you see my screen?
Yes.
Yay. All right, you can only hold 4 things in at once. The way humans hold more than that and deal with things bigger than that is by chunking, by making some sort of boundary or categorization or abstraction around the things currently in our head, and then all of those things become one thing, and we can then add more in our heads. So boundaries, that's how we break things down and make things bigger in a relatively organized fashion. How can we put boundaries around this giant application? Some people will do model view controller. That's one way. That's totally helpful. I worked at a place that was really huge on layers and really wanted to break the application down into many layers. And then all the features would flow through the layers into the giant database at the end. Oh yeah, okay, the architect totally loved this, but he was wrong. This didn't help at all because every feature, we had to change every layer. So it was a big snarly mess anyway, and frankly, we were better off with just 2 boxes and the cylinder. All right, so layers didn't work. Next, there was service-oriented architecture. And I was on a project that was an early implementation of SOA, and we broke our application up into like different parts. And so instead of function calls, we were communicating through the enterprise service bus. And this was supposed to provide separation. And the messages would flow through the bus and through us, but we still shared one giant backend database. So that's one problem, because I'm sorry, if your services are using one database, one collective shared database, it's like having 2 faces, but being attached at the digestive system, and that is not 2 services, that is one app with 2 APIs. You can't be attached at the back end and still call yourself an independent service. That wasn't even the only problem. There was also the problem that the enterprise service bus was responsible for all the difficulties in the communication. So it was supposed to handle backwards compatibility, routing, some translation, and pretty soon it became the bottleneck for all changes, and nobody could get anything done because the enterprise integration team was swamped. And that big snarly mess was in there and in the database. So finally, these days, we have a different iteration of service-oriented architecture, and we call it microservices. First thing to know about microservices, size has nothing to do with it. They don't have to be any particular size other than the upper bound of can you fit the whole thing in your head, which is limited by how good your abstractions are in between. So refactoring will help with that. And by maintained, the app can be maintained by a team of 6. That's Conway's law. Conway's law is pretty much a law of physics in software. Don't try to violate it, just work with it. All right, so it's not about the micro. What is microservices about? Well, one thing it's about is the connections between the different services. Every service can call every other service. Some people implement this with just one bus. I don't. And each service is responsible for being a good citizen in calling everything it calls and in supporting everything it supports. This is a lot of work. You need to deal with things like back pressure. You need to do error handling. You might need to do threading to take care of slow services calls, do some of them in parallel, but throttle it so you don't overload it. Basically be an adult and take care of your own emotional health. Handle your errors, cache what you need to cache. It's a lot of work. These services that are busy talking to each other in a responsible way wind up being a lot of code around a very small core of business logic. And everything else is glue. Everything else is about hooking the other pieces together. That sounds like a bummer, but I think we should embrace it because it keeps our pieces independent. Basically, this is single responsibility at the application level, at the separately released and independently responsible for its own health application level. The benefit of that is that we don't have to contend with all the bats at once. Each application, which has its own independent data store, has to deal with a few bats that are relevant to it. So if this is authentication, say, well, security is probably really important and availability is crucial, but you don't need 10 millisecond response times. If this is the search component, then you do need pretty good response times. You need to hold a ton of data, but you don't have to be the system of record for that data, and you don't have to return the same result every single time. Close is good enough. We can get a balance of trade-offs and solve only the problems that affect this portion of our software system when we break our applications down to a single responsibility. The result looks kind of like this. This programmer thought he would produce one uniform edifice, and he didn't. But you know what? He's doing it right. Each portion of that construction, that system that he's built, is internally consistent. And each portion is solving a different problem. You can tell one of those houses is on a hill, and the other ones are balanced according to the problems that face them. They're connected either with stairs or ladders according to their needs. And you know what? I think he built a really nice looking system there. Just a matter of changing your standards of beauty a little bit. Speaking of beautiful, you'd think our microservices architecture would look like this, right? But the thing about every service being able to call every service and having backwards compatibility and all these other things is that, well, every service can call every service. And your snarl of complexity has been pushed out of the code by very well factored small applications. And now it's in between. And what's more, no one system is holding all that information of who calls who. All you can really hope to do is put good monitoring in there so that you can figure out in a past tense who called whom and who is sending requests to where and things like that. So there you have it. Complexity is now outside the code. Let me tell you why this is awesome. Moore's Law. I used to scoff at it because Moore's Law says that computing power doubles for the same price every 18 to 24 months. And I laughed at that and said, that is not a law, that is a historical trend, which is true. It has been a historical trend in like processor speeds, and we've reached the limit of that. we've hit the speed of light, and processor speeds have reached some sort of limitation because they're as small as we can get them. But the thing is, our software capabilities have not stopped increasing. Our smartphones have not stopped getting exponentially more cool every couple years and useful, and our standards have gone up. The reason for this is Moore's Law is a thing. It's spelled M-O-R-E. As we keep getting more and more tools, more and more software and hardware tools that fit together and build on top of each other. So it's not just the CPU anymore. You've got all the caches, and you've got the graphics cards, you've got the drivers and the operating systems, and then you've got like high-level languages and DSLs and IDEs, and then we've got version control, and we've got various databases, and we've got build tools like Shake and Bake and Cake and Rake. All of these things build on top of one another, and everybody's published on GitHub. We just keep climbing. But oh my gosh, that's a lot of stuff to know about. If this were so easy, I mean, isn't this is kind of like what we were promised with object-oriented programming a long time ago, that we would get reuse and our development curves would accelerate. But I've never actually been in a project where my development curve accelerated. It's usually quite the opposite. The thing is, technology as a whole, not an individual project, we still are exponentially increasing in what we can do. And that's because we're building on reusable components, not classes. Those aren't reusable. A component is reusable if it is released on its own cycle and on its own schedule. And it's reusable by me if I understand it from the outside. If I know how to use it, know when to use it, know what it's for, and know how to take advantage of it. Now that's asking a lot for the crazy number of tools that are out there. But this is how we defeat the bats. Because every one of those boxes represents a solution to some problem that developers have, which are in turn represented by this representative collection of bat drawings. There's no silver bullet anymore, but we can defeat each of these bats. Think of it like you can technically cook anything with a fire and a pot and a good knife, given enough time. But if you want to put together a gourmet meal in an afternoon, and that kind of feels like what's expected of us these days, you need the right tool for the job, and you need to use it efficiently. So maybe this concurrency bat is kind of like cream, and if you want to whip it, you need a balloon whisk. And maybe this bat is a pancake, and this one is a bottle of wine. Yeah, and there is a tool for solving each of these. It's just a different tool for everyone. So there's no silver bullet, but there is a silverware drawer. Yeah. So back in the day, when I started programming was like a puzzle, and it was cool because we could build anything out of. When I started C and the standard libraries and grep and cat and the other Unix utilities that we had on our Linux server, one database, exactly one database, Oracle, and whatever algorithms we learned in school, which we never really used anyway, but still, hypothetically, you had all these puzzle pieces that you could fit together. These days, it's not so simple. These days, we have all the languages. We're all polyglots. Everybody knows JavaScript. And we have everything that's published on GitHub or available on NPM. And for our own productivity, we can brew install a zillion tools if you're on a Mac. And then we don't just have relational databases anymore. There's every other kind of database, and each of them slays its own bat and has its own costs and trade-offs. And then algorithms, shoot, anytime I hit a programming problem anymore that's interesting, that's like abstract and fascinating, that I can really sink my teeth into, like I know this is some sort of set manipulation operation, and I could abstract it to that and then work over it and optimize it for performance. Yeah. Go to the internet. Someone has written a thesis about that and probably published the code on GitHub. So there's nothing like fun and mathy to do anymore because some grad student has done it. And heaven forbid you open source your database when you haven't read the 17,000 papers that are published every week. So the good news is there's way too many tools out there. And the bad news is, this stuff doesn't all fit in my brain. What this means is learning is a first-class task for us. I mean, our job isn't to code. Our job is to get something useful done for the business. And if sitting down and learning about tools or going to conferences is the fastest way to accomplish that, then what are we doing coding? There's a lot of different levels of learning to consider here too. Exploring is what you're doing right now. You're at a conference, good job. You can see what tools are out there that you've never heard of before, among other things, and meet people that will help you later. The spike, the could we possibly use this here, is unfortunately the only learning task officially recognized in Agile Scrummy methodology. Spikes are dangerous, as we learned. Sometimes you get stuck on a technology that has a really good time to hello world story, Elasticsearch, and then you might use that technology for something that it was not intended for, such as a data store of record, and then suffer from it for a very long time. And Elasticsearch is a great technology, but its time to hello world story is deceptive because you can get it up and running super quick, but you should never actually use it with its default configuration in production. And we learned that when it was too late to change it. Right, so Spike is not enough. If you're actually going to use a technology, you've got to step back and familiarize yourself with it. Spend some time getting to know its abstractions, its context, how its world works. I did this with Git a couple years ago when I first started using it. It was getting in my way, and I knew people loved it, so it had to be cool. So finally, I got frustrated enough to sit there and spend 4 or 6 hours clicking through until I could actually read one of the man pages and understand its vocabulary and its sort of worldview. And now I'm hugely productive, and that's some of the best time I ever spent. But it's a pain. It's painful at the time to step back and really familiarize yourself with the tool when you just want it to work right now. And then the hard part. The hard part is understanding the problem we're trying to solve. We need to understand the code that we have in our code base that we're responsible for, and much more difficultly, the business problem that our application or our services are trying to solve. That is the hardest part. In the end, the only way to know whether we're doing it right is to learn whether we're doing it right. And to do that, we have to be able to figure out, so what is doing it right? Our job, in the end, is to have business impact, to make money, probably, for the business, or reduce costs, keep customers on the site longer, whatever people define as the business impact desired out of our software. And if we're doing this, then we're doing good at our job. And if we're not, well, or we want to get better at that. How can we get better at that? To do that, we have to close a feedback loop so that we can learn. In America, we push for practice, 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 but that's actually not how you get better at something. It's practice and reflection. In order to reflect, we need to know how we did. So we code some software, and the users interact with the software, and somehow that software needs to interact with us and report back and tell us, am I working in production? Because I don't care, working in test, you don't get paid for working in test. Working in production. Are people using it, and are people finding value from it? Is it having business impact? There's a lot of this in the lean software movement, where they emphasize the build, measure, learn, loopy thing, except it's actually start with learn. That's the important bit. And then build something and then learn some more. How do we get our software to teach us whether it's doing a good job? I think of it kind of like TDD. We used to write code and then try to test it, and that turned out to suck. So now we write tests, and if we write the test first, then we wind up writing testable code. Yay. But just is it working isn't enough. if we want to actually learn whether it's helping, whether it's having business impact, and learn how it's working so that we can like sort out some of that complexity that's outside that we can't get our hands around, we need to think about that before we write the tests. So we start with learning. In order to learn, we're going to need to measure. So we're going to come up with metrics. I want my service I need to be able to turn on logging so I can see who's sending requests and what's going in and out. That's just, is it working sort of thing. More significantly, I needed to tell me how long users are staying on the site, because that's a business impact that we're trying to have, is for people to stay on the site longer. And then I need you to tell me whether they're interacting with this feature, so I know whether this feature makes a difference. Once I know the measurements, I will put those measurements in the test. Part of the test will be, and it sent this metric. How do you know it's working? Well, it sent this metric. And then, of course, you put that in the tests and it winds up in the code. Now, we haven't done this in the past, and yet somehow, as an industry, we make progress. I think of it's kind of like in evolution, you have natural selection, leaving only the best ones. Well, we have that in the marketplace, hypothetically, only the best software wins. So we can let the marketplace do the selection, and just go out of business if we don't magically become good enough, or we can do that internally at the feature level, and we can learn which features are helping and cut out the ones that are not helping. That's really the way you keep your box from getting bigger and your yarn from getting more snarly, is you don't implement and you don't continue having implemented features that aren't helping. All right, but in order to do all this learning, we can't just program anymore. When I started, this is what we did. We wrote code and somebody else tested it and somebody else did the data model, and maybe hypothetically somebody evaluated it, but I doubt it. And somebody else took care of the networking. And it was kind of like that layered software system where you sliced it horizontally in this case, except that every feature impacts every step. And you can't learn whether you're having the right impact when you slice up the steps like this. If the only feedback I get is how many bugs went into QA, that's not going to help me have business impact. It's only going to help QA. So now, in order to learn, each of us has to be responsible for all of these. And oh my gosh, that's a lot of bats. Of course, there exist tools to help with all of these, but they're not trivial. I can't just like push a button to deploy my software, because every deployment environment is different, because every service and every application has different deployment trade-offs that it needs to worry about, availability and distributedness, and does it need to be in different regions and stuff like that. Oh my gosh. Now at a large scale, one way companies deal with this is this sort of not horizontal division of responsibility. An entire team, the engineering tools team, is responsible for providing the tools to feature developers to let them make the deployment decisions. But the engineering tools team sort of elevates their ability to do that by providing all the information they need and then the buttons they need to do it, abstracting away the dirty details and serving up the important details to support decisions that are within the feedback loop. And the same with evaluation. I think Etsy has a framework that they use for evaluating different features and things like that. And you can have a whole separate team developing utensils that other developers then use. But I need to see the entire impact. I mean, imagine coming into the retrospective, and one of the things we talk about is, oh, that feature that we deployed 2 weeks ago, yeah, we've got it in 20% on, 80% off A/B test, and the test users are staying on the site half again as long, and half of them are interacting with our feature. And that would be awesome. That would be like so fulfilling. Right. So this whole thing, it lets us do the programming, program interacts with the users, and then we close that loop with the evaluation. Once this loop is closed, we get the real feedback loop, which is when we go back and think about how can we do this better? How can we have even more business impact? at Outpace, where I work, it actually does kind of work like this a little bit. But I know at most places we're not the ones making the decisions of which feature to implement yet. The business people are. So then how can we support them in their decision making? For any given project or feature, what we want to know as business people, I think, is how much money are we going to make and when? So that's going to be revenue minus costs. So we come up with a number for revenue and a number for costs, and we say, how much money will we make? Except, of course, it doesn't work like that. We don't actually know how much money we're going to make. So the marketing, I have no idea which department would do this. The business people come up with a range, a probability distribution. What is the relative chance that we'll make each amount of money that will revenue will take in this amount of money as a result of this project or feature? And then they come up with this range, a confidence interval of, we're 90% sure it's between here and here. One way we help them with that is with iterative development. So if we come back with a prototype of the feature that they ask for first, then they're able to take that hypothetically and say, oh, yeah, this is going to provide the impact that we wanted. This looks right to us. Maybe they do market research with it, I don't know, or maybe they evaluate who likes it. One way or another, they're getting a better idea of the benefits of that project. So developing iteratively and pushing something to show all the time helps people narrow the uncertainty in revenue. What about the cost? Of course, we're all asked for estimates in numbers. Tell me how many days this is gonna take. And of course, we have no idea because that would be predicting the future and that's impossible. But we come up with numbers anyway, and then they're always wrong. And I don't know, I'm over feeling bad about that. But coming up with numbers is dumb. Really, we don't know how much it's going to cost, and we should also be coming out with a range. I mean, I don't know that how many days it's going to take, but I do know more than nothing. For instance, I could tell you that adding this feature, there's no way it'll happen in less than 2 weeks. And if it took more than 4 months, I'd be embarrassed. Okay, that's my 90% confidence interval. It's somewhere in there. And if the business people are like, oh my gosh, we can't make a decision about whether to invest in this project if we don't know that. And we're like, but the bats, we don't know which of these 5 problems are going to hit us here. And if they do, we don't know how we're going to solve them. And there's probably ones we haven't thought of yet. And then they say, oh, okay, well, how about you figure some of that out? And then maybe your early iterations are research focused. Which bats are we going to encounter and how will we solve them? And you can spend a lot of time early in a project narrowing that range. That's a win. In the end, it comes down to also business direction. What matters more to the decision of whether to continue with this feature or this project? Is it the uncertainty in the cost, or is it the uncertainty in the revenue? Once we acknowledge that uncertainty exists, then we can talk about how much uncertainty is there and how much value is there in spending time reducing it, spending time understanding the problem and learning about those million tools that might knock it out of the sky. Oh, one other consideration, really quick, is that cost here, it's not just a straight subtraction. There's more to it than just the cost. This also incorporates how long is it going to take. And that says how long is it going to be before we start realizing this revenue, before we take in this money we're excited about making. That impacts the risk level as well. So it's not just business impact. We also need to minimize the time until business impact. And that's a tricky goal because it often leads people to push for feature implementations early and fast. When I was working on this talk, I wrote a simulation of a team in in Scala using actors. And I had all the little people on the team work, and take no time for tests or refactoring. Just get it out as fast as they could. And so the the features started coming out pretty fast, but then it leveled off. And meanwhile, they created so many problems along the way because they weren't refactoring and they weren't doing a good job testing, and that they spent a lot of their time firefighting, and the system spent a lot of the time being unreliable. Then I changed the parameters and I gave the team some slack and was like, take twice as long to do the features, but write more tests and refactor and stuff. And I made it come out like this, a much more level curve, slower at the very beginning, but more predictable and therefore less risky, and a lot more reliable so the users don't have to worry about, is the system going to be up today? I think Netflix must do this because today, an hour ago, when Netflix wasn't available, my kids like exploded in tears because that's an extremely unusual case. So that's a consideration when you're deciding how much time to put into learning about the text you're using and being careful with them. Personally, at work, on my current team, we pushed a bunch of stuff out to production. I wasn't on the team at the time. Anyway, pushed stuff out to production really fast, which was awesome until we hit scale, and then we're spending all our time firefighting, and we really want to replace Elasticsearch because it was the wrong technology, but this represents how much of the app is actually working right now, and it's not regularly very much of it. I think Elasticsearch is trying to strangle us with problems so that we can't replace it or upgrade it or anyway. It's a bad thing to not understand the technologies before you commit to them. And the new refactoring is now restructuring. And by restructuring, I mean replacing whole components, whole databases. That's a lot scarier, and it has a lot bigger payoff, and it's what we're working on now. We don't just want to minimize lead time to business impact. We want to sustainably minimize lead time to business impact. We don't want our curves to go like this. We want to flatten them out, or even better, make them accelerate. And to do that, we've got to keep learning. I think of everything that we learn as like adding lift to our team. So if our project is a hot air balloon, we're adding hot air every time we learn something. And also inside the top of the balloon is like the features that are having business impact. But the thing is, every time we implement anything or do any feature work, we're always adding to both parts of the balloon. Because the more features you have, the more complexity you have and the more pain. And every new feature comes with the unwritten requirement of, oh, and everything else still works, which makes it an exponential complexity thing. Right, so every feature is both a rock and potentially lift. Now, if you're measuring the business impact of a feature, you know which ones are adding lift and you keep those. And you get rid of the ones that are just rocks. But in the meantime, the rocks are also everything we don't know about the technology. There are, of course, bugs, hard-coded things that are going to be a pain in the ass and bite us later, commented out tests, or worse, tests that look like they test something and don't. These are all rocks that are dragging us down. And every time we stop and step back and improve one of those tests, we're throwing out a rock and or adding lift, adding productivity. I mentioned that every feature is always putting things in both sides of the room. There's a special thing about learning tasks. We look at the probability distributions. I love these. You don't really ever know how much a feature is going to cost until after it's done, or even not then. A random few of them, you're going to hit a snag, and it's going to be like, oh my God, this is never going to be done on a time that's worth it, and you're just going to give up. There's that long tail of uncertainty if you don't actually know what's going to happen, how much it's going to cost. The learning tasks are the opposite because you typically time box it. I'm going to spend 2 days figuring out how to get our Elasticsearch cluster configured better, or I'm going to spend 6 hours learning about Nginx configuration, and that's going to help me every day for the rest of my life. The learning work has a fixed cost and a long tail of benefits. You never know which of the umpteen learning tasks we undertake, which of those yaks is going to be the golden yak that once you shave it and then you publish your build tool on the internet and then suddenly you're famous, and people ask you to be on podcasts. And anyway, you never know what's going to happen with those learning tasks. So there's a balance there of well-expected business impact versus I don't know what the benefit's going to be, but it might be really awesome. So in a sense, I think of like the learning as like the fire, and then you've got your business impacting features as like the puffy air, and it looks pretty. In order to measure that though, if I'm going to learn, am I increasing my team's lift? Am I decreasing the rocks? One thing I'm trying right now at work is I've made a little survey with 4 free-form qualitative questions, and you can type in there, what's the new help that I knew I put in today? And what things that were already in the system helped me? And which ones bit my face? Elasticsearch, because we're using it wrong. And then if I saw anything, like if there was a test that was broken and I just commented out, I know I just put a rock in the basket right there, and I can document that. I had reasons for doing it right then, but at least we can try to notice whether we're increasing our stocks. If I take the time to do something like add a command line option to one of our utilities, and then the following week I see in the things that helped me box, oh, that command line option was really helpful, then I know I've won and I'm doing something useful. It's something I'm trying. I'm hoping that this will help us measure the stocks of lift and weight that our team is working with. In the end, there's always going to be way more that we need to learn than we can learn. Way more, just ridiculous. And there's way more complexity in our system than we'll ever be able to understand all of it. I think of it kind of like politics. If you look at environmentalism, okay, just to take a relatively safe subset of politics, and you can worry about carbon emissions, or you can worry about the trash clogging the oceans and stop using plastic bags. Or you can worry about, forget the bags, the pandas are so cute. We gotta save the pandas. There's no way for everybody to help with everything. And if we even put the effort into prioritizing everything, we'll never get anything done. So our choices are to care about everything and become despondent because we can't fix it, or to care about nothing and do nothing, and that doesn't accomplish anything either. In this case, human irrationality comes to the rescue, and we all care about some particular part. Some people care about pandas because they're cute. Other people care about the litter in their yard because they personally can do something about that. And we hope that enough people happen to settle on the most important things, that something gets done and the world doesn't die. I'm not optimistic. But still, it's kind of like the bats that we suffer from. Can we knock down the most important ones for our team? Now, we can do better than random, unlike in human society at large. And if we identify the bats, then we can look for volunteers in our team and say, okay, you are in charge of knowing about security, and you are in charge of understanding our concurrency framework. And while everybody should be worrying about these things all the time, that's impossible. So the good part is we're not alone. We can each take what we personally feel passionate about and make that our specialty. And where we find gaps, where there's bats that are biting us, you see that in the surveys, then we can ask somebody in the team to learn about that. One interesting point about this is it makes it part of your job to learn about a specific area, and that's helpful because it's easier to justify spending time on it. This is where like 20% time comes in. I don't think it should be 20% do whatever you want. I think it's more like, okay, I'm going to spend 80% of my time doing what the business tells me is important, what the people above me think is important, and 20% of the time doing what I know is important, but they don't know about. The things, the problems that we see at our level that will bite us eventually if we don't take the time to fix them. But shoot, the people above us have other things to worry about. They have whole other flocks of bats to deal with. And it's not even just our team. Within our organization and within our community, we can work together. Just today at our stand-up, Eli was complaining, I can't send a string to the Clojure JDBC library to connect to SQL Server. It blows up. There's a bug. And he's like, maybe I'll spend a day and fix it and submit a pull request, which would be awesome. But if Eli doesn't have the day, then Nate points out, he's like, so Eli, did you look at the mailing list or submit an issue yet? And Eli was like, no, but I definitely will. So even if he doesn't have time to fix the problem to help the larger community, he will put the information out there. And maybe there's some other developer out there with the correct can opener for string connections to SQL Server who will say, oh, I know how to fix this, and she'll fix it in like 5 minutes, but only if she has the information. So we need to work with our team, and we can work with our community to keep accelerating us as an industry and within our own companies. In the end, we can't get rid of complexity. We can push it back as much as we can with greater and greater abstractions within our code. We can push it back by keeping our apps small enough to be single responsibility. And then we can add monitoring and tracing around to learn about the complexity that's outside the code. But we have to accept that learning is part of our job and embrace that. Keep it in our tasks and keep it at the front of our design. We also need to acknowledge uncertainty, accept that it exists, and then we can work on reducing it as necessary with research. And finally, work together. We can't do this by ourselves. But if we each fight the bats that are most interesting and most immediate to us and share that work with each other, then as a community, we can beat back entropy and keep reaching for the sky. I'm Jessica Kerr. I hope you enjoy the rest of JS Remote Conf. Here are some awesome books. How to Measure Anything in particular is a business book and talks about the uncertainty things if you get pushback at work for giving people a range. These slides will be on SlideShare, but that didn't work right before this, so you'll have to wait a little while for that. Thank you.
All right, thank you, Jessica. I'm sure everybody is clapping and applauding madly. It was such a good presentation, and definitely some things there that I think we all need to learn. What?
There's lots of clapping in the chat.
That's right. I'm going to go ahead and turn on Q&A mode. If you have a question, you can hit the button and the Ask a Question button, and it'll turn on your audio so that you can ask Jessica the question directly. If you don't have a microphone or you're not in a position to do that, go ahead and type it in the chat, and I'll go ahead and read it. All right, we have a question from Mark B. I know from experience this takes a second because you have to accept the request for control of your audio or whatever. So we'll just give them a minute to jump in.
You might have to hit allow in 4 different boxes.
Yeah.
Oh, I guess that didn't work.
Mark says he'll just type it in.
Okay.
Oh, there we go.
This is Archana.
Hi,
Archana.
Hi. You had mentioned at the very end about using other people in your team and your community as sources of knowledge. Do you have any ideas of how to advertise that you have this knowledge? I mean, if it's in a community, it's a little different, but in your team or in your, not just your team, but in your organization.
Oh, that is a great question. I've been thinking about how to do that lately, because it's like sometimes you have a problem and you don't know that like the person in the next cube is an expert in that, and it's kind of like you have an unknown known that you didn't know you had that resource available. So a couple ways that we do this at Outpace is we have sessions we call Learn You a Thing. Some people have lunch and learns. And we share something, whatever. We give a little presentation to the other people at work, which is fun. And then they know you know about that. But I've been wondering how we could advertise other expertise. We have Slack, and maybe other people have IM. You can put things in your description. I think it would be really cool to have like an internal site, something searchable, which apparently is a challenge. The wikis are never are. That people could post a very brief bio for stuff like that. I haven't seen it done well. Does anybody else have ideas? Post them in the chat. Oh yeah, sorry for no headphones.
That's all good. Okay, so the next question that we have is, how do you get the boss? Any suggestions for getting the boss to carve out enough time for learning?
I'm lucky enough to work at a place that values it and wouldn't. But one thing is to, if you can take a particular example, if you can find or share stories of how a particular technology made things a lot easier and saved lots of hours, really in the end, it seems ridiculous to spend our time coding when there's all this existing tested working code out there that we could be using. So there's definitely a productivity argument to make. Also, if you can track the bugs or issues in such a way that you can like blame it on a particular tech that you use but don't know enough about, that's a good way to justify, hey, we need to spend time learning about this. And that's another good thing to post questions on chat or suggestions in chat.
So another question here from William is, you mentioned tracing. What technologies have you put into place to accurately trace communications between your microservices?
Usually just logging, really. Yeah, I don't think we've had a need beyond that. There's a lot of like log harvesting stuff. I know we use Splunk. Logging is the easiest to do, and these days it's pretty easy to, well, I don't know about easy, but it's certainly possible to get really detailed analysis of those logs. So I haven't done anything like that, but some other people have. Yeah.
All right, Juan, do you have a question? Maybe we're having an audio issue there. I'll ask the next question in the chat, and that was, what were the 4 questions you ask on a daily basis?
Oh, I could actually post a link to my survey, I think. The 4 questions are, what did you do today that, or actually, first, my favorite question, the most fun to answer, is what got in your way today? That's where you get to complain about all the problems that you had and what slowed you down. And then there's what helped you today. What knowledge or features or just general like tests show up in there a lot. What helped you get work done today? And then there's what new help did you add today? And that includes learning. That totally includes help that exists only in your head. And which would be another way to advertise what you know, I guess, is if these surveys make it up to a wiki, that would be a source of who knows what. And finally, there's what new hurt did you either add, or that's kind of rare, recognize and not fix. So like if you saw a test that was commented out but didn't do anything about it, that would go in the new hurt danger box.
Very nice. All right, one more question. I'm going to ask 2 more questions, and then we're going to have to move on so that Brad can do his presentation. But the first one is, can you give a few example of microservices, maybe some that you've encountered or created before?
Sure. Let's see. Outpace is, I think, the only place I've worked that called anything a microservice. And even then, we don't always call it that because we don't want it to get associated with the giant message bus of doom. But let's see. There's one that just receives events from the client, for instance. Its only job is to receive, like, somebody clicked this, somebody did this activity, somebody saw this, and it just throws them on Rabbit. And separately, there's other little bits that grab those and persist them in, unfortunately, Elasticsearch. And then there's separate programs that, some of these are actually batch processes. It's still a micro or a small single responsibility application. They go back and analyze those events. Or there's another one that like reads that event stream from Rabbit and just stores things in Redis so that we don't like spam the same customers with the same ads repeatedly. So it kind of keeps track of who's seen what, and that's its only job. Well, I guess those are some examples.
Awesome. Oleg, do you have a question?
Yep. Can you hear me?
Yes.
Yep.
Okay, awesome. Thanks, Jessica. It was really great talk. My question is, what do you use for microservices coordination? So is it just HTTP requests between microservices, or you use database for kind of tasks or message queues?
Yeah, that's a great question. As far as coordination, I'll say we don't. They're not coordinated, but some of them talk to each other over HTTP, just REST JSON requests. Some of them talk over RabbitMQ, so there's that receiver that throws stuff on Rabbit, and then anybody can pull it off of Rabbit, so that's a different one. Queues are great because they really decouple things very well, because then nobody's waiting on anybody else or affected by the other person's speed. You can use the queue to buffer that. But really, I recommend having a standard like REST and JSON or something that you deviate from when there's a reason to. Like, we want to throw it on Rabbit because we want multiple services to be able to draw from it. And that's a difference from the default, which that difference then becomes information. There's something different about these particular messages.
But one more small question. What about the case when we have to wait when several microservices will finish their tasks so the third one can continue with its job?
Oh, yeah, we totally do that. So then you've got like a concurrency thing going on, and we'll have, well, we're working in Clojure, so we use core async for that in some cases. Where you've got to divide a task up, and it'll be each one of the ones you're waiting on will happen in a different thread, and then you'll have another point of execution waiting for each of those to come back, and then continuing with the response. That's a strength of Clojure, and really of the JVM in general. In a single threaded language, you can use promises for that. Some promises library will let you compose them like that. That's definitely a challenge.
All right. Well, it is 9 o'clock, so it's time for Brad's talk. I think there were 1 or 2 questions left in the chat. Federico had a question, and I think there might be 1 or 2 other things that folks want to chat with you about. So if you have time and you want to answer them in chat, that would be great. Thank you again, Jessica.
Thank you.
All right. Well, we're just going to take maybe 2 or 3 minutes so that Brad can get all set up, and then we will start up again.